discuss about arithmetic sequence. So here in arithmetic sequence or in arithmetic progression, first of all, formula is equal to an is equal to a1 plus n minus 1 d. So here a1 is first term, here d is common difference. What is meaning of common difference? If I write 8, 11, 14, 5. So this is called arithmetic sequence because difference between two consecutive terms will be equal to d and this will be equal to same. If there is difference 3, so there is also difference 3, and between 11 and 14 d is equal to 3. So this is called arithmetic sequence. So general formula of arithmetic sequence will be equal to an is equal to a1 plus n minus 1 d. So we will do question number 1 of exercise 6.2, which is given as write first four terms of the following arithmetic sequence. So first part is given as a1 is equal to 5 and terms are 23, 26, 29 are in arithmetic progression. We can also say that arithmetic sequence or arithmetic progression. So if a1 is equal to 5 and 23, 26, 29 are terms of arithmetic progression or arithmetic sequence, so we had to find a2, a3 and a4. So to find a2, we know that general formula is equal to an is equal to a1 plus n minus 1 d. So for a2, here n will be equal to 2. So a2 will be equal to a1 plus value of n is equal to 2. So 2 minus 1 and d. So this will be equal to a2 is equal to a1 plus 1 d. So a2 will be equal to a1 plus d. Similarly, a3 will be equal to a1 plus 2d. Similarly, a4 will be equal to a1 plus 3d. So here what is value of d? D is equal to 26. D is equal to 26 minus 23 because D is common difference between two consecutive terms of the sequence. So D will be equal to 3. So A2 will be equal to A1 is equal to 5. 5 plus 3 will be equal to 8. This will be equal to 5 plus 2d will be equal to 6. So this will be equal to 9, and similarly this will be equal to 5 plus 9 will be equal to 14. So a2, a3 and a4 are 8, 9 and 14. Here in second part, value of d is not given and value of a1 is not given. So we know that here in a5 is equal to 17. So here in a5 n will be equal to 5. So general formula a5 will be equal to a1 plus n minus 1 d. So this will be equal to a5 is equal to a1 plus 5 minus 1 will be equal to 4d. So if we can write a5 as a5 is equal to a1 plus 4d. a5 is equal to 17 will be equal to a1 plus 4d. This is equation number 1. Similarly, if I write a9 will be equal to a1 plus 8d. a9 is equal to 37, so 37 will be equal to a1 plus 8d. This is equation number 2. So from equation number 1 and equation number 2, so from equation number 1, which is equal to 17, a1 plus 4d, and equation number 2 is 37 is equal to a1 plus 8d. So if we subtract, so this will be equal to plus minus minus, this is cancelled, so this will be equal to minus 4d is equal to minus 20. So 4d is equal to 20, so d will be equal to 20 over 4 will be equal to 5. So value of d is equal to 5. We will put value of d into equation number 1. Put in 1, so value of a1 will be equal to 17 is equal to a1 plus 4 5, so this will be equal to 17 minus 20 is equal to a1, so a1 is equal to minus 3. So after value of a1 and d, our second term a2 will be equal to a1 plus d, a3 will be equal to a1 plus 2d, a4 will be equal to a1 plus 3d. So a1 is equal to minus 3 plus 5 is equal to 2. So our second term will be equal to 2, and similarly for third term a1 plus a1 is equal to 5 plus 2 multiplied d will be equal to a1 is equal to minus 3 plus 10 will be equal to 7. a3 will be equal to 7. Similarly, a4 will be equal to a1 is equal to minus 3 plus 15, so this will be equal to 12. Here in third part, 3a7 is equal to 7a4. So if we put value of a7, so this will be equal to 3a1 plus 6d, and similarly 7, this will be equal to a1 plus 3d. So this will be equal to 3a1 plus 6 3s are 18, d is equal to 7a1 plus 21d. So after simplification, this will become 7 minus 3 will be equal to 4a1, and 21 minus 18 will be equal to 3, d is equal to 0. So 4a1 plus 3d will be equal to 0, so this is equation number 1, and from this expression a10 is equal to 33, so a10 will be equal to a1 plus 9d is equal to 33, so this is equation number 2. So from equation number 1 and 2, equation number 2 is equal to a1 plus 9d is equal to 33. So if we subtract these equations, this will become a1 plus 9d is equal to 33, and second equation is 4a1 minus 3d is equal to 0. So in equation number 1, coefficient of a1 is equal to 1, so we will multiply this equation by 4, so this will become 4a1 plus 36d is equal to 132, and equation number 2 is equal to 4a1 minus 3d is equal to 0. So if we subtract, so this will be cancel out, and this will be equal to 39, and this will be equal to 132. So 39d is equal to 132, so d will be equal to 132 over 33. So D will be equal to 4. So after putting the value of D into equation number 1, so 4a1 minus 3 is equal to 0. So a1 will be equal to minus 3. So value of a1 is equal to minus 3 and value of D is equal to 4. So our a2 will be equal to a1 plus D and a3 will be equal to a1 plus 2D. a4 will be equal to a1 plus 3D. So a1 is equal to minus 3 plus 4 will be equal to 1, minus 3 plus 8 will be equal to 5, minus 3 plus 3 4 is this will be equal to 12, so plus 9. So this is our arithmetic sequence. Question number 2 is given as if an minus 3 is equal to n minus 5, find nth term. So we know that an minus 3 is equal to 2n minus 5. So if we replace n by n plus 3, so this expression will be equal to a n plus 3 minus 3 2n plus 3 minus 5. So this will be equal to 2n plus 6 minus 5. This will be equal to an will be equal to 2n plus 1. This is solution of this question. Question number 3 is a5 is equal to 16. So we know that a5 will be equal to a1 plus a5 will be equal to a1 plus 4d. So a5 is equal to 16 will be equal to a1 plus 4d. This is equation number 1. And a20 is equal to 46. So a20 will be equal to a1 plus 19d. So a20 is equal to 46 will be equal to a1 plus 19d. So this is equation number 2. We had to find a12. So from equation number 1 and equation number 2, if I write equation number 1, 16 is equal to a1 plus 4d, and equation number 2, 46 is equal to a1 plus 4d. So after subtraction, minus minus minus, so this will be equal to this is equal to 19d. So this will be cancelled out and this will be equal to 30, minus 30 will be equal to minus 15d. So d will be equal to 2. So after finding the value of d, we will put this value into equation number 1, put in 1. So this will be equal to 16 is equal to a1 plus 4 2. So this will be equal to 16 a1 plus 8. So 16 minus 8 is equal to a1 will be equal to 8. So after finding value of a1 and d is equal to 2, so we had to find a12 will be equal to a1 plus 11d. So a1 is equal to 8 plus 11, d is equal to 2. So this will be equal to 8 plus 22. So 8 plus 22 will be equal to 30. So a12 will be equal to 30. This is our question. Question number 4 is given as we had to find a13. So this is an arithmetic sequence or arithmetic progression. So here first term will be equal to x and d is equal to common difference, means from any value we will subtract second value. So if we write this will be equal to this will be equal to 2 minus x. So common difference will be equal to 1 minus x. So a13 will be equal to a1 plus 12d. So a1 is equal to x plus 12, d is equal to 1 minus x, so this will be equal to x plus 12 minus 12x, so this will be equal to 12 minus 11x, so a13 will be equal to 12 minus 11x. In next question we had to find a18 term of the sequence. So a6 is equal to 19, so a6 will be equal to a1 plus 5d, so 19 will be equal to a1 plus 5d, so this will be equation number 1. Similarly, a9 is equal to 31, so a9 will be equal to a1 plus 8d, so 31 will be equal to a1 plus 8d, so 31 is, this will be equation number 2. So from equation number 1 and equation number 2, 19 is equal to a1 plus 5d and 31 is equal to a1 plus 8d. So after subtraction, this will be equal to 31 minus 19 will be equal to 12, this will be equal to 3d, so 12 will be equal to 3d, so value of d will be equal to 4. So after putting the value of d into equation number 1, put in 1, so equation 1 will be equal to 19 is equal to a1 plus 5, d is equal to 4, so 19 is equal to a1 plus 20, so a1 will be equal to minus 1. So we had to find 18 term will be equal to a18 will be equal to a1 plus 17d, so a1 is equal to minus 1 plus 17d is equal to 4, so a18 will be equal to 60, 1734, so this will be equal to 67. So which term of the arithmetic progression 5 2 minus 1 is minus 85? So we know that formula is equal to an is equal to a1 plus n minus 1 d. So which term means we had to find value of n will be equal to what? So an is equal to minus 85. Here first term a1 is equal to 5, d is equal to 2 minus 5 is equal to, d is common difference between two consecutive terms, so d is equal to 2 minus 5 will be equal to minus 3. So a1 is equal to 5 plus n minus 1, so we had to find value of d, so n, so d is equal to minus 3, minus 85 minus 5 will be equal to n minus 1 minus 3, so this will be equal to minus 90 divided by minus 3 is equal to n minus 1, so this will be equal to 30 is equal to n minus 1, so 30 plus 1 is equal to n, so 31 is equal to n. So minus 85 is 31 term of the arithmetic sequence. So here in this question we had to find value of n. a1 is equal to minus 2, d is equal to 10 minus 4 will be equal to 6. So an is equal to a1 plus n minus 1 d. So an is equal to 148, a1 is equal to minus 2 plus n minus 1, d is equal to 6. So 148 plus 2, this is minus 2 here will be equal to plus 2, n minus 1 6, so 150 is equal to n minus 1 6, so 6 is multiplied here, so here this will be equal to 150 over 6 will be equal to n minus 1, this is equal to 25 is equal to n minus 1, so n will be equal to 25 plus 1 is equal to 26. Here in this question, how many terms are there in arithmetic progression? How many terms means we had to find value of n. An is equal to a1 plus n minus 1 d an is equal to 68, a1 is equal to 11 plus n minus 1, d is equal to 3. So 68 plus 11 will be minus 11 is equal to n minus 1, 3. So 68 minus 11 will be equal to 55 is equal to n minus 1. Sorry, this will be equal to 57 n minus 1, 3. So this will be equal to 57 divided by 3 is equal to n minus 1, because 3 was multiplying here, so here this will be divided. So 57 divided by 3 will be equal to 19 will be equal to n minus 1. So 19 plus 1 will be equal to n, so n is equal to 20. Question number 9 is, if nth term of arithmetic progression is 3n minus 1, so find arithmetic progression. So first term will be equal to n is equal to 1, so a1 will be equal to 3, 1 minus 1. This will be equal to 3 minus 1 is equal to 2. This is same as question number 1. N is equal to 2, so a2 will be equal to 3, 2 minus 1. This will be equal to 6 minus 1 will be equal to 5. N is equal to 3, so a3 will be equal to 3, 3 minus 1 will be equal to 8. So arithmetic progression will be equal to 5, 8. Here is difference of 3, 11, 14 up to so on. This is arithmetic progression. Here is question number 10. Determine whether minus 19 is term of the arithmetic sequence or not. So here a1 will be equal to 17, d will be equal to 13 minus 17. So 13 minus 17 will be equal to minus 4. So here this is value of an will be equal to minus 19. So an will be equal to a1 plus n minus 1d. So an is equal to minus 19 is equal to a1 is equal to 17 plus n minus 1d is equal to minus 4. So if value of n is positive number, then this will be equal to term of the arithmetic sequence, otherwise it will be not. So this will be equal to minus 19 minus 17 will be equal to n minus 1 minus 4. So minus 19 and minus 17 will be equal to minus 36 will be equal to n minus 1 minus 4. So this will be equal to minus 36 over minus 4 is equal to n minus 1. This will be equal to 36. So 9 is equal to n minus 1. So n will be equal to 10. So it means minus 19 is term of the given arithmetic sequence. Similarly, second part of this question number 10 is, 2 is term of arithmetic sequence or not. So an will be equal to a1 plus n minus 1 d. Here a1 is equal to 17, d is equal to minus 4. So 2 is equal to 17 plus n minus 1, d is equal to minus 4. So this will be equal to 2 minus 17 is equal to n minus 1 minus 4. This will be equal to minus 15 is equal to n minus 1 minus 4. So this will be equal to minus 15 by minus 4 is equal to n minus 1. This will be equal to 15 by 4 plus 1. So this will be equal to 19 by 4 is equal to n, because this is not natural number 19 over 4. So 2 is not the term of the given sequence. Next question is, if L, M and N are pth, q and rth term of the AP, we know that if n term is an is equal to a1 plus n minus 1 d, this is n term. If this is p term, so this will be equal to ap is equal to a1 plus p minus 1 d. If this is q term, so this will be equal to aq will be equal to a1 plus q minus 1 d. If this is r term, sorry, n term, r term, this will be equal to a1 plus r minus 1 d. So here this term as name as L, this named as M, this is named as N. So here we will write L is equal to a1 plus p minus 1 d. Similarly, M will be equal to a1 plus q minus 1 d. Similarly, N will be equal to a1 plus r minus 1 d. So after putting values of L, M and N into this equation, so this expression will be equal to a1 plus p minus 1 d multiply with q minus r plus M is equal to a1 plus q minus 1 d into r minus p sorry, plus N is equal to a1 plus a1 plus r minus 1 d into p minus q is equal to 0. After simplification, this will become a1 plus after multiplication with q minus r, so this will become a1 plus pd minus d q minus r plus a1 plus, if we multiply q and 1 by d, so this will be equal to a1 plus L is pth term, M is q term and N is equal to r term. So after putting the value of L, M and N into this expression, our final solution will be, this will be equal to P M minus N. M is equal to A1 plus QD minus D minus N is equal to A1. This will be minus RD P M minus N. M is equal to A1 plus multiply D with Q. So this will be equal to QD minus D minus N is equal to A1 plus RD minus D plus this value of Q N minus L. N is equal to A1 plus RD minus D minus L is equal to A1 plus PD minus D plus R. This value of L will be equal to A1 plus P minus 1. So this will be equal to PD minus D minus, and M is equal to A1 plus QD minus D. So after simplification, this expression will be P A1 plus QD minus D minus A1 minus RD plus D plus Q A1 plus RD minus D minus A1 minus PD plus D plus R. A1, this expression will become A1 plus PD minus D minus a1 minus qd plus d is equal to 0. So here a1 will be cancelled out with a1, d will be cancelled out with d with d, a1 with a1, a1 with a1, d with d. So our next expression will be qd minus rd plus qrd minus pd plus r uh, plus qrd minus pd plus rpd minus qd is equal to 0. So this will become pqd minus prd plus qrd minus qpd plus rpd minus qrd. So all of these will be cancelled out, so 0 will be equal to 0. This is proof of the question. Here in this question, we will write 4, 7, 10 as arithmetic progression. So a1 is equal to 4, d is equal to 7 minus 4 will be equal to 3. So an will be equal to a1 plus n minus 1 d. So a1 is equal to 4 plus n minus 1, d is equal to 3. So this will be equal to 4 plus 3n minus 3. So this will be equal to 1 plus 3n. An term will be equal to 1 plus 3n. So general term or n term of this sequence will be equal to an is equal to 1 plus 3n over 3 raised to the power 2 is general term of this sequence. Here in this question, if 1 over a, 1 over b and 1 over c are in AP, we know that if three values are in AP, their common difference will be equal to same. So if 1 over a, 1 over b, 1 over c are in AP, so difference will be equal to 1 over b minus 1 over a. This will be equal to 1 over b minus 1 over a. Similarly, second common difference will be equal to 1 over c minus 1 over b. So we know that this difference and this difference are same. So if d is equal to d, so 1 over b minus 1 over a will be equal to 1 over c minus 1 over b. So this will become 1 over b plus 1 over b is equal to 1 over c plus 1 over a. So this will become a plus c over ca. This will become 2 over b. So value of b will be, after cross multiplication, b will be equal to 2ac over a plus c. So this is proof given in the question. So similarly, question number 14 is 1 over a, 1 over b and 1 over c are in AP. So we know that if these are in arithmetic progression, 1 over a, 1 over b, 1 over c, so difference will be equal to 1 over b minus 1 over a. So similarly, we can write as difference will be equal to 1 over c minus 1 over b. So if we add these two equation, this is equation number 1, equation number 2. So 2d will be equal to, this will be cancelled out with this, so this will be equal to 1 over c minus 1 over a. So this will be equal to a minus c, 2d. So d will be equal to, here if we write next part, so d will be equal to 2 is multiplied here, so there will be divide. So a minus c over 2ac is value of common difference d. This is proof of this exercise. This is complete solution of the exercise 6.2.